Kia ora team. I'm hoping that you can hear me. This is our live stream on solving linear equations and linear inequations. So please can you comment if you can hear me? This will give me a chance to see if my audio is working. This is my second ever live stream, so I'm not sure it'll be working. So it'd be really useful if you could comment. It's working. Perfect. Fantastic. Okay. So stream is up. Can you hear me? If you can hear me, just say yes. So, perfect. So today in the stream, I wanted to talk about solving linear equations. Linear equations are quite standard. We can start with a simple linear equation like 2x plus 7 is equal to 15. Okay, very simple equation, very simple solution. We've done this since year 9. So, how do we solve this? Well, we subtract 7. 15 take 7 is 8. And then we divide by 2. 8 divided by 2. I'm going to write it as a fraction because a fraction is really useful for me, and then see if I can simplify the fraction to give me 4. This is how I would solve this linear equation. Is that hard? No. Well, how could I make this linear equation a little bit more challenging? Well, I could make it a little bit weirder looking. I could go 2x plus 7 over 2 equals 15. Right? So, guys, I'd rather you use the comments to communicate with me instead of each other. You can do that in your own time. Thanks, guys. So if I use this question, how would I change my approach? Would I do anything different? And I don't think the answer is I would. I'd probably just keep it the same way. I'd multiply by 2. And what's 15 times 2? 30. Okay? And if I take away 7, I'm not doing anything too dissimilar to what I did at the start of this one. The only thing is I have 23 divided by 2, which is, well, 23 over 2. I could write it as a decimal, but for me, fractions are fine, so I'm going to leave it like so. And so, even though I've stepped up the intensity, the answer is not that different. And so, solving linear equations in this way, as long as you're taking steps that you do the same thing to both sides, you should be fine carrying through and doing some pretty gnarly looking questions. I'm going to try another question. This time I'm going to make it a bit weird. And this time I'm going to have 3x plus 2 equals 5x plus 3. So this equation looks a bit weird. Can we solve it? Give it a go. Once you have given it a go, then I'll go through it with you. All right. So some of you may have said that the first thing to do in this kind of situation is to expand. So I'm going to do that, see what happens. 3 times x gives me 3x, and 3 times 2 gives me 6. And that's equal to, what's 5 times x? 5x, and 5 times 3 is 15. So I haven't done anything different, I've just expanded. And now what do I have to do? All of the x's to one side. I've got to move all of the x's to one side, right? And so my aim is to move all the x's to one side, so I'm going to move the 5x. So I will go 3x take away 5x. 3x take away 5x, negative 2x plus 6, 15. Then I take away 6 from both sides. 15 take away 6 is 9, and then I divide both sides by negative 2. And once again, my answer is a fraction. I'm going to write negative 9 on 2, and that is going to be my answer. Can you still hear me? Because I can't hear anything, well, see anything in the comments, so you've got to tell me, yes sir, that makes sense, sir, no sir, that doesn't make sense, sir. Please help. Thanks, guys. Alright. This, even though it seemed a little bit more complicated, I had to do pretty much the same kind of algebra. So solving linear equations, the only way I could make this more complicated is making the equations have more fractions, change them around a little bit more, do something more interesting. But I don't think linear equations could change much. The solving process is the same as what we did in level 1. Expand if you need to, simplify if you need to, deal with fractions if you need to, but you should be fine in this kind of setting. Now, what will make this a bit harder? This first video is going to be quite easy because it is linear equations, and linear equations is fine, but we need to try and move to linear inequations. Inequations. What are inequations? Inequations are equations with inequalities. Equations with equalities, equations. Equations with inequalities, inequations. Nothing too crazy there. Inequations, fancy. But the maths doesn't change much. So if I had 2x plus 7 before I had equals 15, but this time I'm going to change to is greater than 15. How much does my maths change here? Does it change a lot or a little? I'm going to let you think about it. Comment if you know whether it changes a lot or a little, and then I'll just continue. And in fact, this is not the only symbol I could use. I could use a less than sign, a greater than sign. In fact, there's a whole range of signs I could use. I could use equals, which we know, greater than, less than, greater than or equal to, or less than or equal to. You know, all of these signs can be used in these equations. And so I'm going to go back to the greater than sign I had. The algebra shouldn't change. So Let's subtract 7. What's 15 take 7? 8. This sign doesn't change. And then I divide by 2. Does anything change? No. And the reason it doesn't change is because, well, let's have a little bit of a number line. Okay. And what I'm going to do is I'm going to have, hello ruler, ooh. Right, here's a number line. Right, on this number line, I'm going to put 0 here. Okay. Now, if I picked a number and I called it x, yeah. Now, suppose I had 3. What is the relationship between x and 3? X is greater than 3. But what about in the upside down with the negative space? If I had negative 3, where's negative x sit? Is it here or here? And in fact, you'll find that negative x is here. So what's the statement I can make about these two? I can say that negative x is less than negative 3. Do you notice that even though like x is greater than 3, negative x is less than negative 3 because this is lower and this is higher. And that's really important because watch this. How do I swap between this equation and this equation? Well, I just multiplied by negative 1 and I multiplied by a negative. And if I multiply by a negative, or I could have divided by negative 1, I flip this sign. And that's the relationship that's really important. Because when you flip in the mirror, 3 is still closer to 0 than x was. Negative 3 is closer to 0 than negative x. And that's the crux. This is where that magical rule comes from. Like people say, when you multiply by a negative, you flip the sign. This is why. Because you're still just as far from the 0. Okay? Same if I divide. Okay, so let's try a question that needs this. So I'm going to write it out first. When you multiply or divide by a negative number, you flip the sign. Okay? Now, does that make some sense? If so, let's try this question here. Question 2. All I'm going to do is I'm going to go I better put in an inequality. Okay. And then this question here. Try these two questions and tell me what you get. What happens? What's the sign situation? Do I flip the sign on both of them or not? Okay, so some of you have said you change your algebra a little. And I'm saying you don't really change it at all. The only thing is that if you multiply or divide by a negative, you flip the sign. So, once you've done, can you put your answer in the comments? Let's see how we go. Okay. Thank you, Michael. Yes, you're right. You only flip the sign on question 3. Let's see how that works out. I subtract 7. 1 minus 7 is negative 6. So I have a negative, but I'm not going to flip the sign because I'm not dividing or multiplying by a negative. But if I divide by 2, what's negative 6 divided by 2? That's negative 3. Okay, the negative is still there, but it's not what I divided by. Over here, negative 2, add or subtract, it doesn't change things. And when I divide by negative 2, this is when I flip the sign, because dividing by a negative flips the sign. And so now I have. So let's have a look. Daniel, well done. Annie, well done. Zitong, well done. And Ben H, I'm not sure. Just make sure you check, okay? Because here the negatives don't cancel out in the first question or in the second question. And in the third question, the negatives do cancel out, but you're flipping the sign. And there's the difference there. It's what will make things a little bit more awkward. And if you can understand the nuance of what just happened, this will make a lot more sense when we start using inequalities and things like quadratics and things like that. Because inequalities become something that should become almost second nature to us now. And so I'm going to give you guys a few more inequalities questions, and we're going to see how we go. So I'm going to leave these up the top so you know when you need to flip and when you don't. And I'm going to give you quite a few questions. So, question 4. 3x minus 1 over 4 is less than 14. 5. 5x plus 2 over 6 is greater than 1, or I'll make it greater than or equal to 1. Question 6 is 5x plus 2 is greater than or equal to 3x minus 3. Okay, and then the last one for now is going to be x plus the 3 over 3 is less than or equal to x minus 7 over 2. Okay, see what kind of answers you get. Yeah, it's all right, Ben. Stuff like this happens because what we do is we focus so much on the maths. No, it's okay. We focus so much on the maths, we forget the small things, right? So have a go at these 4 questions. See how it goes. And then what I'm going to do, bit of a surprise, is I am actually going to do some quadratics as well. Not super hard quadratics, just the really easy ones that use inequalities, because they're going to be really useful for us very soon. So give these a go and see how we go. once you're done, please put your answers in the comments so that I know people are doing this, rather than me staring blankly at a screen. Now, Jay, I like your first answer. That's very nice. Matt, check your working. I think it's really important. Remember, you're multiplying by the 4 first. When you multiply 14 by 4, you'll get 56. And then 56 plus 1 will give you 57. And then you divide by 3. So you should get okay. So what I want you to do is just check the answers with the people in the comments. But this one here, you should get 5x plus 2 is greater or equal to 6. You subtract 2 is greater or equal to 4. X is greater or equal to 4/5. Once again, for question 5. Okay, because you multiply by 6. So 6 times 1 is 6. And then you subtract 2. And then you divide by 5. Now, I'm seeing a lot of answers. Cool. James, nice. Yeah, Angela, that looks good too. Joshua, I'm going to ask that we don't use decimals because decimals are not going to help. But I'm seeing a lot of people with negative 19 over 2 for question 5. Is that because I'm not sure why that you're getting negative 19 over 2. Can you check those people getting negative 19 over 2 for question 5? Can you check? Or maybe you did 4, 5. There we go. That's probably why. Got to check the order in which you do these questions. Question 6. Yep. Let me just do that in here. So I get 5x plus 10 is greater than 3x minus 9. Then I'm going to subtract 5x. So I'll get 10 minus 2x. Then add 9. So 19 is greater than, and then when I divide by negative 2, I'll flip the sign, and so it will be okay, greater or equal to negative 19 over 2. Yeah, some of you may have just subtracted 2x from this side, which probably would have been a bit smarter. Sorry, I didn't see that. And then for the last one, I'll multiply across, and so I'll get 2x plus 3 greater than 3x minus 7, 2x plus 6 greater or equal, less than or equal to 3x minus 21. And then once again, I am going to subtract 3x. So this is negative x plus 6, negative 21. I'm going to subtract 6, so negative x is less than or equal to negative 27. So dividing through by a negative, I'll flip the sign once again. Okay. Yep, Enoch, sorry this is too easy, but remember this is for everyone, okay? Um, so those 4 questions really, really unpack the kind of thinking that you're needing to do. You probably don't need to swap the sign most of the time, but sometimes, depending on how you do your algebra, you might need to swap the sign. And that's what I want you to be a little bit careful of, okay? So check when you need to swap the sign and check when you don't need to swap the sign. Now, at this point, we've had 26 minutes of this live stream. I'm gonna move on to a slightly different section. I'm gonna just quickly talk about how we might do this for quadratic equations. Okay, because that's probably where we're gonna get to next. If, however, you're still wanting to practice some of these questions, you can go and practice them in your workbook and do as much as you can. These kinds of questions up on page 41 and 42 of our workbook. They get a little bit more challenging, but page 41 or 42 in our workbook, if you so wanted to carry on with this. However, you could probably even do page 40. However, I want to just quickly look at a small bit of factorizing and solving. So stay on if you want to do that. I'm only going to do this for 10 more minutes. Okay. So let's try this. Is that okay? Or would you guys like me to do more questions like this? Okay. Just waiting on someone to respond to my questions. Fantastic. Okay, I will move on to quadratics. Fantastic, thank you. Quadratics. This is not overlapping in what we did in class, or what we will do in the next few streams, but I think it's really important that we look at factorizing in quadratics and how inequalities fit into there. So I want to look at a really simple question. Okay, how would you solve this equation? This equation doesn't really, it's not too bad, but what you do is you go 2 things multiply together to get 0. So when is this 0? Or when is this 0? So I solve and we get x is less than 1, or sorry, x is negative 1, or x is 2. Marcus, thank you. Factorize might be the right answer, but I've already factorized because the whole point is I think factorizing is something we can do. So I'm just going to go from the fact that we have factorized. Okay, so for question 2, should this be any different? How would you solve this? Okay, watch it. Anki, I think. Anki's on. Um, yeah, that's correct. Just check your minus signs, everyone. Yep. I just can't see it on the screen sometimes, but yeah. So check your minus signs. But how would this equation change it? Would it be that different? Now, the answer to this question is actually no, it doesn't change much. But what I'm going to do is just comment on the fact that here we have inequalities, equations, equal signs, right? Here we have an inequality. So things are going to slightly change a little bit because a quadratic represents a parabola. Okay, and this is going to be really useful for us when um, we have graphs. That's our next topic. And a parabola looks like this. Okay, and so if I were to draw this, this is telling me, I'm now calling back to level 1. This is saying that x is either -1 or x is 2, right? When is this parabola equal to 0? Well, on the y-axis, it's equal to 0 when x is -1 or x is 2. And that's really, really useful because this picture will help us plan the next part. Because if this front part is a parabola, then so must this. And my question is, when is this parabola greater than 0? And I go, well, if this line tells me when it's 0, above this line is positive, and below this line is negative. So just visually, when is this parabola above 0? It's this part here and that part there. Those are the parts that are above the x-axis. And so, Ankizong, close, but not quite. Because x is greater than 2 works, because when x is greater than 2, all of this is fine. But x is greater than 1, all of this is underneath. So in fact, it's actually x is less than 1 on the number line. And so you want x is less than -1 and, or x is greater than -2. It's either after this point or before this point. After this point or before this point. And that's a little weird. I'm just going to leave that for a second. And then ask, how do you think this question would go then? When is this parabola less than? Less than 0. How would this answer change? If this is the greater than 0, when is it going to be less than 0? And if you can see, I don't know why no one's responding. This is awkward. This is still the same parabola. And so when is this parabola below the axis? Well, it's between this point and this point, isn't it? Yeah, Annie, that's outstanding. I like how you've stated your answer, but I'm just going to say x is greater than -1 and x is less than 2. It's that in-between space. And Zitong, I like what you've done as well. Or some people use or, I use and, but it's okay because it's a range. And if you put this here and then -1 is less than x, can you sort of see that in fact you don't need to write x out twice, but you can write -1 is less than x, which is less than 2. And in fact, you have a unique single interval. We say this is -1. Sorry, no, we don't say -1. We say x is between -1 and 2. That's kind of cool. Now, I don't want to spend too much time on this. I think it's really important that we visualize by drawing a parabola. I think when we get to doing this stuff, this is going to be really useful for us. But if you'd like to practice these kinds of questions, page 58 has them, but they're not nice because some of them are harder to factorize than others. But if you'd like to try, page 58. How do we write your answer, Monique? I would write your answer like this. Or this. Right? Oh, not like that. Yeah. So, or this. Either of them, any of them are suffice. Okay, Mr. Jupp says, and I think it is better as an interval with two distinct endpoints. Yeah, this is probably the best, but if you wrote this, we're not going to frown at you. Okay, so page 58 in your book, you can try more. I don't really want to do too much more of these today, but I will do one more just to keep, you having the option to do one more. So question 4 is going to be x squared plus 7x minus 8 is greater than 0. See if you can work out that. Okay. Okay, it's slightly different. What are you going to need to do? Yeah, Monique, if you get a chance to write your answer, always write your answer. That way it makes sense for me as well. What's the first step? It starts with F and rhymes with actorize. Yes, we factorize. So this one is x plus 8 minus 1. Yeah, because 8 and -1 multiply to -8 and they add to 7. And so what I'm going to do is I'm going to rough sketch this, some parabola, draw a line, and then, well, this will give me 1. This will give me -8. So I better draw my black line over here somewhere and go 1 and -8. These are going to be really useful for me. Fantastic, fantastic, fantastic. And so now When is my parabola greater than 0? What are my answers going to be? On the x-axis, once again, Annie, yes, it's going to be x is greater than 1 and let's use or x is less than -8. Now, Mr. Singers, I like the fact that you've written this. You said that -8 is greater than x and x is greater than 1. But can you find a number that's between -8 and 1, but is bigger than 1 and smaller than -8? Does this make sense? And the answer is no. You can't write it like that. You can only write it in this form because it's not in one interval. Whereas if my question was less than 0, sure, you will do the same maths, and then you can comfortably go, yes, x is between 1 and -8, or -8 and 1. All right, because that's really important. It's a very small, very common mistake to make, but it happens all the time. And so I want you to be careful. You can only write it as an interval if it is an interval. See, this orange interval exists, but the green ones are not an interval, right? So that's going to be me for the day. I've been live streaming all day. So page 58 in your book for this stuff, page 42 and 41 for the other stuff. I am going to wrap it up there, and then tomorrow we're going to talk about exponentials and logarithms. That's really useful. I will see you then. Thank you. If you have any questions, feel free to just put them on the Google form. Thank you, team. I'll see you later. You've been good.